All right, y'all. In this section, we're now talking about analyzing histograms. Remember when we analyzed histograms, a couple things that we first considered were the characteristics, characteristics of shape, modality, center, range, outliers, and gaps. We're going to get in a little more detail about how to do the center and range in a second. This one, we're really going to focus on the shape, modality, if there are outliers and if there are gaps. And so if I look at this first one, remember we had three different types of shape. We talked about it being symmetric, talked about it being left skewed or right skewed. We did talk a little bit about uniformity whenever there's a uniform distribution, but we're not going to focus on those really. Symmetric, remember, was pretty much the same on both sides. We talked about being able to think about it like, hand grenades and horseshoes. If it's just about the same on both sides, we're going to count it. So this one we're going to label as symmetric. This one over here, remember when we talked about our skewness, we had like this mouse looking thing and the tail was to the right. Since the tail's to the right, we'll call this skewed right. This one over here, tail's to the left, so we'll call this skewed left. And then this one over here, it does look symmetric on both sides, right? Even though it has these two humps, it looks fairly similar on this side as well on that side, so we're actually going to call that one symmetric too. All right, now let's move on to modality. Remember with modality, you're looking for how many humps that you have, right? In this first one, we could really draw one hump, so I'm going to call that unimodal. And that would be the same thing for these. One hump. Same on the bottom. But then we get to this one, and as you can see, we go down, up, and so in this case, I'm going to call that bimodal. Don't forget, if you have three or more humps, we call that multimodal, but in this case, we're going to focus on just the unimodal and the bimodal. Outliers, remember outliers are going to be if you had a bunch of space and then you had like a little outlier way over here. Outliers are data values that are way, way far away from your data. There was a more particular answer that way that we checked it whenever we were in 10th grade and 11th grade, but we're pretty much just going to look at outliers as something that's way far away. This idea of gaps, don't forget, this is not a gap just because there's a space. A gap has to have data surrounding it. So you're going to have a column and then a space and then a column. And so we'll look at that in the next one. And then range. Remember, range is going to be just the range of your data from starting point to ending point. We're not really doing that subtraction because we don't really want exact values dealing with histograms. And then centers. Don't forget, we kind of talked about how to be able to measure center by estimating. There was another way that we did it to make it a lot better. But remember, it should be about the same on both sides when you think of this idea of weight. So in this case, we can't just go to the center column and say, hey, that's the center right there, because there's less weight on this side than what there would be on that side. And so we would have to adjust, keeping that in mind, and maybe call the center in this column over here. But we'll get to the particulars here in just a second. Looking at this question. So this one was from one of your practice things, and it asks you to be able to identify the shape, modality, center, range, if there's outliers or gaps. And so the first ones I'm going to get out the way. Notice we have a gap right here. We have data. We have a space or a frequency of 0, and then we have data again. So this one does have gaps. I'm not going to consider these outliers because they're kind of grouped together. It's a good chunk of our data over here. Outliers I would probably consider a little further away and maybe just secluded by itself. So I would say no outliers. Our shape, in my opinion, I see a chunk of our data and I see a tail this way. So I'm going to call that skewed right. Remember, our tail's facing the right. That tells us how it's skewed. Modality, in terms of modality, I myself, excuse me, let me draw that again. I myself see one hump, and so I see it as unimodal. I could understand where people might argue that there's two humps by going down and then back up. To me, it continuously goes down, so there's one hump. But if you considered it two humps, that would be bimodal. And then for our range, I'm going to go ahead and erase these real quick. Remember to find range. We talk about our beginning, so 0.5 to 4. So that's how we're going to denote our range. I'll write it as 4.0 because that's what they have. But 0.5 to 4. And then for our center, remember for our center, we had to go ahead and we labeled how our frequencies on each column. So this one happened 4 times. This one was 7. This one looks like 3, 3, looks like a 2, and then a 1. And so we labeled those, and after we labeled those, we added all of them together. So we had 4 plus 7 is 11, plus 3 more is 14, plus 3 more is 17, plus 2 more is 20, or 19, plus 1 more is 20. We took that and we divided by 2 in order for us to find our center. Basically what we're saying is there's 20 data values. We want to know the one that's in the middle. And so we found our center by doing that. We ended up with 10. So then we would have to count out where the 10th data point would be. So in this case, we kind of talked about using checks. There's 1, 2, 3, 4. This column had 4 checks. We're still not to the 10th. We got to keep going. So there's 5, 6, 7, 8, 9, 10. So this is lucky number 10. We had 7 possible checks in there. Didn't take 7. Just the 6th one gave us the lucky number 10. So then we're going to use these values in order to write our center. So our center is going to be 1.00 to 1.50. All right, the last thing you need to be able to do with analyzing histograms is you need to be able to read a histogram similar to this and be able to answer questions based off of it. So the first thing I'm going to do whenever I see something like this, I'm going to go ahead and write out my frequencies. This one's a 3, an 8, a 10, a 5, and a 2, because that's going to come into handy here in just a second when we answer these questions. It says, how many trees do you think were measured? Well, if we have frequencies, we can go ahead and add those together and get how many trees were measured. So we got 3 plus 3 is 6, plus 8 is 14, plus 10 is 24, 5 more is 29, and 2 more is 31. So we know that there's 31 trees measured. It says, can you identify the exact height of any of the trees? Why or why not? Remember, this is a histogram, so we don't know the exact height. We know intervals. So I'm just going to say it's a histogram. Uses intervals. So we're not going to have exact heights. So if somebody were to say, hey, based off of this, how many trees were 73 feet tall? You'd have no clue. You know that 8 trees were in between 70 and 75, but that'd be it. So some other questions you might see from this would be, how many trees are taller than 75 feet? And so in that case, you would have to add those sections that would represent taller than 75 feet. Remember, there was an issue that everybody had with this, that word at least. I'm just going to write this down also to give you a little clue with something. Everybody was struggling with this word, at least. All that means is whatever that number is and anything more. So that number and greater. So if I said at least 70, well, I want to know 70 and above. I want to know 70 and greater than that. And then the last question says, well, what would you expect the median height of the cherry trees to be? So the median, don't forget, that's our middle value. We would do the same thing that we did on the first one. We've already know that there are 31 trees, so we would take that 31, we would divide by 2, and we would end up getting 15.5. So this one's going to be kind of interesting, but we want the 15.5th data point. So what we're going to do is kind of our checks, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15.5, that data value is going to be somewhere in here. So it's in between 75 and 80. So we don't know the exact value, but we do know it's in between 75 and 80. Depending on what you're talking about, also probably could have used 75 and 79 because we know that 80 actually starts our next column. So now go ahead and work on your histogram question, or your analyzing histogram questions, and then we'll go on to the next section after that.